Welcome back, everyone. In this video, I will continue going over the lecture for the trig derivative section. Now, in the previous section, or previous video rather, I went ahead and showed you the formulas for all 6 trig functions, and we talked about deriving sine, how you could derive cosine's derivative, and then we actually did derive tangent's derivative formula and described how you could do the other 3 as well. Well, what we're going to do is just think about those 6 formulas as being more additions to our toolbox, and now we'll be able to do derivatives of more and more functions. And at this point, we really can do the derivative of a lot of different types of functions. We can do exponential functions, trig derivatives, power functions, and we can add, subtract, multiply, and divide. We have rules for all those. So let's go ahead and look at some problems. Number 1 says find f prime of x and f prime prime of x. We want the first 2 derivatives if f of x equals 2e to the x times cosine of x. And then, just for the sake of making sure we're practicing plugging in and doing things correctly, what is f prime prime of x? Or f prime prime of pi over 4? Well, of course, we got to do the first derivative first before we can get the second derivative. Let's go ahead and do that. What rule do you want to start off here? We are multiplying, which means we need to do the product rule. And the product rule says we do the derivative of the first, that's going to be 2e to the x, times the second, cosine of x, plus the first, 2e to the x. Wow, I'm going to write that kind of weird. It's not 2 to the e. 2 times e to the x power, times the derivative of the second, cosine of x. Now do the 2 indicated derivatives. The derivative of 2e to the x is itself. The derivative of cosine, well, actually that's just cosine of x. I'm getting ahead of myself looking over here. Plus 2e to the x. And what's the derivative of cosine of x? That is negative sine of x. Now, how do you want to simplify this? There's a lot of ways to simplify it, but probably not surprising at this point. We just did the product rule with an e to the x, and we can factor it out. And especially because we need to do the second derivative, we should factor it out. So take out the 2e to the x. And what are we left with? We have cosine of x in the first term and plus negative sine of x, so just minus sine of x in the second term. All right, so that is the first derivative, and it's simplified. We know we can't do anything to combine cosine and sine because they're completely different trig functions. So this is good. But now let's do the second derivative. That's what we want to do. Notice we want to do the derivative of the first derivative there. Let me go ahead and just write it down like I usually do. We're doing the derivative of 2e to the x times cosine of x minus sine of x. And now what do you want to do here? You should say we need to do the product rule. And you are correct. We do want to do the product rule. Again, the product rule says do the derivative of the first, which is 2e to the x, multiply it by the second, which is cosine of x minus sine of x, plus the first, 2e to the x, times the derivative of the second, the derivative of cosine of x minus sine of x. All right, so let's go ahead and do our indicated derivatives. The derivative of 2e to the x, we know again is 2e to the x. We multiply it by cosine of x minus sine of x. And then we have plus 2e to the x. And the derivative of cosine of x is negative sine of x. The derivative of sine of x is cosine of x. Because we already have a minus there, then it's going to be minus cosine of x. All right, we've done our 2 indicated derivatives. And kind of we're at the last derivative we're doing, so maybe we wouldn't want to simplify it, but it's always a good habit to simplify even if you don't have to do more derivatives. We have a 2e to the x in common, so let's factor it out. We get 2e to the x, and the first thing we have cosine of x minus sine of x, and when we factor it out of the second term, we have a minus sine of x minus cosine of x. Now, can we simplify here? We definitely can simplify here because we have quite a bit that happens. For one, We have a cosine of x and a negative cosine of x. Those go away. But also we have minus sine of x minus sine of x, which is negative 2 sine of x. We have 2e to the x times negative 2 sine of x. Well, we don't really need to have parentheses anymore here because we're not adding or subtracting anything. We can just multiply these and we get negative 4e to the x times sine of x. Oddly enough, it looks like the formula for the second derivative is a lot neater than the first. And that's, it's really because we only have sine of x here. We had cosine and sine of x there, but simplifying, you can see why I would want to simplify this. If we have to plug in, which we do, not really that easy plugging in here. At least it's much shorter, and that's preferred. All right, so we've got f prime prime of x. Now we want f prime prime of pi over 4. All right, and pretty much as always, we want the exact value, which means just plug in pi over 4. And if you can simplify anything, then do that. We have 4e to the pi over 4 times sine of pi over 4. And e to the pi over 4, definitely don't have any clue what that is. Oops, but I should probably actually write pi over 4, not switch to pi over 2 for no reason at all. But still pi over 4. And then what is sine of pi over 4? Hopefully you remember the unit circle, or at least some things about it. This is the square root of 2 over 2. And yes, you are expected to know the exact values. Don't give me a decimal here. If an angle we have is on the unit circle, which pi over 4 is, it needs to be an exact value. You can simplify a little bit more because the 4 can cancel out with the 2 down here. Oops, that would be a 1. And we have actually no fraction at all, which is great. It's a little easier to read. We have negative 2e to the pi over 4 times the square root of 2. And you could rearrange that depending on what you like. If you want to put the e to the pi over 4 in the back, you could, because it's just multiplication. But that is our derivative, second derivative actually, at pi over 4 of this function. All right, number 2 here. Number 2, we want to find dy over d theta if y is theta times secant of theta times tangent of theta. Right? This is another one where we know we want to use the product rule, and we talked about in the last section, what do you do if you have 3 products? Well, it's best to think about it still as 2 products, and then just see how everything works out. But we still want to use the product rule here. I'll use this as the first, theta times secant of theta. And then tangent of theta will be the second. All right, but once again, just set up starting with the product rule. Dy over d theta, we do the derivative of the first, d over d theta of theta times secant of theta. Let me actually clean that up. That doesn't look like it's easy to read. Theta times secant of theta times the second, tangent of theta, plus the first, theta times secant of theta, times the derivative of the second with respect to theta, tangent of theta. And we know the thing to do here, we want to do these 2 derivatives, and the alarm should be going off in your head. Well, I still have a product here, which means we should do this one on the side, figure out this derivative, and then plug it in and simplify from there. So that's exactly what we're going to do. I'm going to do this derivative on the side because it's still a product, just like I did in the last section. D over d theta of theta times secant of theta. I don't know why my brain wants to write the c and secant as part of a parentheses. Secant of theta. And now in this one, just kind of reset. First is theta. We're going to do the product rule. The second is secant of theta. And just to make sure I keep it separated visually from this one, I'll keep doing it in green. The product rule says do the derivative of the first, d over d theta of theta, times the second, secant of theta, plus the first, theta, times the derivative of the second secant of theta. And now we can directly do these derivatives because we do not have any more products or anything like that. The derivative of theta with respect to theta, well, that's just 1 because it's just the variable. So this is 1 times secant of theta plus theta. What's the derivative of secant of theta? You probably have to look at your hopefully formula sheet that you made a little bit above, or at least wrote down the formulas. The derivative of secant of theta is secant of theta times tangent of theta. Now you might be looking at this and saying, well, you can factor out secant of theta, which you can, but I'm actually not going to use that. I'm not going to use that just for the simple reason of it's only a part of what else is going on here. It might not be worth it trying to plug it in and with factoring prior. So let's just go ahead and plug this in directly. The derivative of theta times secant of theta we just figured out is secant of theta plus theta times secant of theta times tangent of theta. Oddly enough, I think it's kind of funny that this was our original function right here, but that's not really that important. All right, and this whole thing is being multiplied by tangent of theta plus theta times secant of theta. And then we want to multiply by the derivative of tangent of theta, which is secant squared of theta. Once again, you may not have these memorized yet, and I understand, to look at the formulas that we made before. Now, one thing to notice here is that we have a whole bunch of thetas and secant of thetas and tangent of thetas. It's pretty hard to read. The one thing I would do for simplifying purposes is at least distribute this tangent of theta through and see, can I actually simplify anything? And if you can, great. If you can't, don't worry about it. Now, when I distribute through, we get secant of theta times tangent of theta. In fact, we might end up making it messier. Who knows? Secant of theta times tangent of theta plus theta times secant of theta times tangent squared of theta. Okay, so that's the first thing. The second thing, we don't have to distribute, but we can multiply the secant of theta times secant squared of theta. It would be secant cubed of theta. And do you see anything that you can take care of here? Well, there's pretty much only one thing you could do, and it's up to you if you want to do it. You can factor out a secant of theta everywhere, but it's not going to help that much because you still have a tangent of theta, a theta and tangent squared of theta, a theta and secant squared of theta. So in all honesty, if you stopped here or stopped here, it's probably where I would stop too. All right, so this is dy over d theta, following the equal signs here, but I'll go ahead and just highlight it so we see it more specifically. This thing down here was just to help us figure out the derivative. All right, so what do we want to do with this equation? We want to find the tangent line at the point pi comma 0. Remember, to find the equation of a tangent line, we use point slope form. Y minus y1 equals m times x minus x1. x1 is pi and y1 is 0. Now, what is m? M is going to be gotten by taking the derivative that we just figured out and plugging in pi. This seems like it's going to be a nightmare, but if you remember some stuff, it's not too bad at all. And one thing you may be hopefully remembering is when you have secant and tangent, they have vertical asymptotes, which means they're not defined at certain numbers. So you do have to make sure that you can actually do the derivative here. But let's just see what we get for m. M is going to be dy over d theta, plugging in pi for theta. And let me go ahead and just give myself plenty of room to work this out. We've got our formula for dy over d theta. I'm going to plug in pi everywhere I see theta. Secant of pi times tangent of pi plus pi times secant of pi times tangent squared of pi, and then plus pi times secant cubed of pi. Once again, I think this one, it looks like I'm still wanting to have my C be the parentheses on some of these. Let me go ahead and make it a little more easy to read. Now the thing here is that if you don't remember what secant of pi is, tangent of pi is, you can rewrite them. Secant's 1 over cosine, tangent's 1 over sine, and you can also use your calculator. All these are going to be whole numbers because it's on an axis. Now secant of pi, that's -1. Tangent of pi is 0, plus pi times secant of pi, again, -1, times tangent squared of pi. Well, this is 0, so this is 0 squared. And then plus pi times secant cubed of pi. Secant of pi is -1, and we cube it. All right, and what you want to notice is most of this is completely going away. Anything times 0 is 0, that's 0. All this stuff times 0 is also 0. But you don't have a 0 here. -1 to the third power is -1 times pi, simplifies, and the only thing we're left with is -pi. So the slope here is -pi. Now if we go ahead and plug it in, what do we have? Well, you get y minus y1. y1 is 0. Actually, I don't know why I wrote y0. y1, I can just get rid of that, equals m -pi times x minus x1, which is pi. And you can just leave it like this, like we talked about before. This is a lot easier to read as far as a tangent line equation because you know the slope and you know the point it's passing through. X is pi, the y, since it's not there, is 0. All right. But yeah, this was a messy one. But the great thing is that, you know, really we're doing the derivative of a lot of different kinds of functions now, especially when you start talking about trig functions. There's so many more combinations than we could have before. And I think it's very useful to see. Okay, so I want to do one more in this video. And the main reason I want to do this one is to really emphasize that when you're doing trig derivatives, it's really important to simplify first if you can. I didn't intentionally try to simplify this one just because I had this theta here. But if you multiply secant of theta times tangent of theta, you won't be able to simplify it. Now, what do I mean by simplify? Well, what I mean is something you should remember from doing trig identities a little bit, if you can think back to trig, is that often if you switch everything to sines and cosines, you can get stuff to cancel out. It's not going to always work, of course, but we should try it. So what I'm going to do, I'm not going to worry about the 4 here, but I want to try to simplify cosine of t times tan of t times cosecant of t. Right, so, and you could probably tell by the amount of room I left that there's not going to be a whole lot to do here. Now, when we simplify, switch everything to sines and cosines. Cosine of t is exactly that. Tangent is sine over cosine. We get sine of t over cosine of t. And cosecant is 1 over sine of t. Now what happens is pretty much everything cancels out, right? We have a cosine on the top, goes with the cosine on the bottom, cancels out. We have a sine on the top, cancels out with the sine on the bottom. And this entire expression, multiplication of 3 trig functions, is just equal to 1. Right, well, what does that mean our function is? Go ahead and plug it in. W of t was 4 times this multiplication of 3 trig functions, and we just figured that it actually only equals 1. And 4 times 1 is just 4. Well, now doing the derivative of a number is really easy. But you saw doing the derivative of a product of 3 functions, especially 3 trig functions above, could be very messy. Luckily, it's simplified so much that we can just do dw over dt, the derivative. It's just the derivative of 4. And you probably just wanted to write 0, and that's fine. The derivative with respect to t of a number is 0. So in fact, this messy thing has derivative 0 just because the equation's actually a very complicated way of writing the number 4. All right, but I'll see you in the next video when we finish up this section.